students, today we have a very interesting topic and that is speed. Now, if I say to you that what comes in your mind when you hear about bullet trains, about supersonic missiles or fighter jets, and what comes in your mind on the other hand when we talk about tortoises, when we talk about ants? Obviously, when we talk about bullet trains and all, we have a imagination that a train which runs very fast, and on the other hand, tortoise is a slow moving creature. Same time, if I talk, have you ever said to your friend while you're moving together, you're going very fast, and sometime maybe you say your friend that come fast. So what I'm going to talk about today is how do we decide a word fast or slow. So this concept all related to a very important, very interesting topic called speed. And then the same topic today, we'll talk about velocity also, who is somewhere you can take as a brother of speed. But they are not same, they are different. But they are treated like the same thing. But there are some differences between speed and velocity. So our class is devoted today to understand the concept of speed and velocity. So let's start with a concept of speed and velocity together. So for this explanation, again I am taking a situation in which an object is traveling from A to B straight, then from B to C. Now from A to B it is traveling a total distance of 8 meter, and from B to C it is traveling 6 meter. According to the previous concept of distance and displacement, what is the value of displacement here? So that will be the shortest distance between initial and final position. So you can guess here, if it is 8 and 6, so according to the Pythagoras property, this whole length will be of 10 meter, and that is the value of displacement. And for distance, we measure the actual path, and that is 8 plus 6, that is 14 meter. That we have come to know. But when we are talking about speed and velocity, then what decides speed of any object and what decides velocity of any object, that is our topic. Now, here we are involving time also. Time means the whole journey of actual length is 14 meter, and if the body is moving from A to C finally, the displacement will be taken 10 meter. Suppose now for this journey, the person is taking 5 seconds. So the whole journey has been traveled in 5 seconds. Now, what do we take for an object about its speed? That is how the object is travelling distance on its path in per unit time. Unit time means here I have taken 5 seconds. So that means time is divided into 1 second 5 times. So for each 1 second, while traveling on this path, what is the distance traveled per second? Total distance is 14, but here we are concerned about the distance traveled on actual path in unit time, that is 1 second. So if I divide this whole journey into 5 equal parts, because there are 5 seconds, so you can get that each length is of 2.8 meter, 2.8 meter, 2.8 meter, 2.8 meter, 2.8 meter, and thus total is 14 meter. But for speed, what we are concerned about, that in each 1 second, how much distance is being traveled. So right now, if I calculate the speed for this object, what will I take? Distance upon time. That means how much total path has been traveled by the object and within what time. So right now, and what we'll get then? We get then distance traveled per unit time. So here for a speed calculation, I have taken 14 meter is the total distance and dividing by 5 seconds. So when I am dividing distance by total time, what are we getting? Distance traveled per unit time, that gives the value of speed. So if I divide 14 by 5, what I am getting? 2.8 meter per second. That means, what is meaning of 2.8 meter per second? This means that in each 1 second, the body is traveling on actual path by 2.8 meter. Now, so what is speed here? Distance by time. That means distance traveled per unit time. Now coming to velocity of the same object, we take care of the displacement traveled per unit time. That means displacement of the object in each second or each unit time you can take. Right now I am taking 1 second. So when the body has been traveled this much of length, actually the body has traveled from position A to position C 10 unit, that is 10 meter. So traveling through this path 14 meter, but while traveling through this path, simultaneously the object is being displaced from point A to point C also. So right now if I compare the velocity of this object with speed, you can see now to get the velocity of the object, the displacement will be taken. So the displacement is 10 meter of the object, and time will be taken 5, because within this same 5 seconds the body has reached from position A to position C. Although we are taking directly from A to C, but the path is actually covered in 5 seconds. So for velocity also the time will be taken 5 seconds only. So for velocity I am taking displacement upon time. So what I am getting? 2 meter per second. What does it mean by 2 meter per second? That means while traversing this distance on actual path, the body is actually traveling or displacing from position A to position C also. So now why it is coming 2.8 for speed and why it is coming 2 meter for velocity, 2 meter per second for velocity? Because that means 2.8 meters per second, that means in 1 second if it is traveling 2.8 meter, same time you can compare that moving on actual path by 2.8 in 1 second is same while traveling directly from A to C by how much? 2 meter. So you can see 2.8 meter is actually equivalent to 2 meter from position A to position C. 5.6 meter on actual path is equivalent in 2 seconds is equivalent to 4 meter traveling directly from position A to C. Similarly, 8.4 meter on the actual path is equivalent to 6 meter from position A to C after 3 seconds. So you can see that while traveling on the actual path, you are actually also displacing from point A to point C. So for speed, what do we get? We get distance divided by time. And for this velocity, what do we get? When we get displacement by time. So when we get displacement time, we get velocity. When we get distance by time, we get speed of the object. So from this calculation, we can come to know that speed and velocity can have different values also. So now, how will we describe velocity? That means 2 meter per second from A to C. And how will we decide speed? 2.8 meter per second on actual path. That means in which direction is the actual path? That doesn't matter. That means speed is a scalar quantity and velocity is a vector quantity, because we always shows the direction as well. Fine. Right now here it is from A to C. Now one question I want to ask. Suppose the body has reached from A to B and moved towards somewhere here to point D 6 meter. Now if I calculate speed, will the value of speed will change if this situation is also covered in 5 seconds? You will see that now 8 is there, 6 is there. So again the distance will be 14, time is 5 seconds. So you will again get the speed 2.8 meter per second. But if we talk about velocity, will we get the different value? No, we'll again get the value 2 meter per second from A to D. But this velocity and that velocity which we'll get will be considered different. Why it is different? Because this velocity is from A to C direction, and the next velocity will be, although they have the same magnitude, but that velocity will be taken from A to D. That means that velocity may be same in terms of magnitude, but if their direction is different, then it will be taken in different velocity. So for the speed, we don't have to worry. In any path, we can take the value, and because direction doesn't matter. But for velocity, matching magnitude will not get confirmed that okay, velocity is same. For velocity, we have to take consideration of direction also. So for example, A to C to going 2 meter per second is different if we are moving from A to D with 2 meter per second, because directions are different. Fine.